guys, welcome back. So today is day 36 of the Daily Arithmetic Challenge. Okay, so on the screen for you now are 6 questions to have a go at. Pause the screen, have a go, and then press play when you're done. There are a couple more on the next screen, but because we've come to the end of the arithmetic paper that we've been looking at, there are actually a couple of reasoning questions on the next slide, which we will go through all together. Okay, so it's time to go through the answers. See, so the first one we have got 5/6 divided by 5. So it's a division of fractions question, so that means we're going to be needing to use KFC. So the first thing that I have done is I've turned the whole number into a fraction, so that I'm dealing with 2 fractions. So obviously 5 whole ones is the same as 5/1 as a fraction, because you're basically saying you have got 5 whole lots of 1. So then I use the KFC method, which means keep the first fraction the same, so I'm keeping 5/6 the same. I'm then flipping my operation symbol, so I'm flipping it from a division to a multiplication. And then I change the last fraction, I change the order of the numbers, so it is 1/5 now. And then as soon as you have it into a multiplication, you can do it nice and easily, where you just multiply your numerators and multiply your denominators. So 5 multiplied by 1 is 5, and 6 multiplied by 5 is 30. Number 32, we have got 24 divided by 10 subtract 4. So this is a BODMAS question, so an order of operations question. So the first thing I look to see if there's any brackets, which there are. So I deal with what's inside my brackets first, which is 10 subtract 4, which is 6. And I've then written that underneath. I have then got 24 and a divide left over. So my question is now 24 divided by 6, which is nice and easily 4. Number 33, we've got 9/10 add 4/5. So the only issue here is that the denominators are different numbers. However, it's nice and easy to see how you could change the 4/5 into tenths. And I would do that by multiplying both my denominator and my numerator by 2. So I'd have 9/10 add 8/10, and that would equal 17/10. Or you could turn that into 1 whole 1 and 7/10, because you would have 7/10 remaining. Number 34, you have got 2,728 divided by 31. So for this question, as you can see, I've written out my multiples of 31. Remember, just physically add them on each time. Then you do your division like normal. So as you can see, I've got 31s into 2 I can't do, so I've put a 0 there, moved the 2 across. I've then got 31 into 27. Again, 27 is too small, so I've put a 0 there, crossed out the 2 and 7 and moved them across. So I've now got 272 divided by 31. Well, as you can see, that goes in 8 times, but not 8 times exactly. So I would subtract that number from 272, and then I have got 24 left over. And then I have got 31s into 248, which, as you can see there, goes in 8 times. Number 35, I've got 7/10 divided by 3, so very much like 31. Turn the whole number into a fraction, which is 3/1. Then use KFC, keep the first fraction the same, which is 7/10. Flip the operation symbol from a divide to a times, and change the last fraction from 3/1 to 1/3, and then multiply together. You've got 7 multiplied by 1 is 7, and 10 multiplied by 3 is 30. Number 36, we've got 2 wholes and 1/3 divided by 3/4. So for this one, I've turned my mixed number into an improper fraction. So that's 2 and 1/3. Well, I've got 2 whole lots of 3, which is 6, and 1 left over. So that is going to be, 7/3. And 3/4 obviously stays the same because it's already a fraction. And then I need to turn them both over the same denominator. Well, 3 and 4 have got 12 in common. So I multiply my numerators by the same number that I've multiplied the denominators by to get to 12. And then I do the subtraction as normal, and I get the answer 19/12. Interesting about this question is it's not as straightforward as what you would believe. So two numbers have a difference of 0.7 and a sum of 1. What are the numbers? So the first thing to do here is to actually understand what the vocabulary is saying to us. So that word difference means if you subtracted the two numbers from each other, you would have 0.7 left over. Basically, if you added 0.7 on from your lowest number, you would get to your highest number. And then the word sum means the total of, to add the two numbers together. So we're looking for two numbers. When we take them away from each other, we get the answer 0.7, and when we add the two numbers together, we get the answer 1. So what are the numbers? So the first thing that I did was do it by a process of elimination. So I thought of two decimal numbers which would add together to give me a total of 1. So for example, on the screen you can see I've chosen 0.8 and 0.2. Now I know if I add those two together, I get 1. So I have the sum of 1. The only issue is when I do 0.8 take away 0.2, I actually get the answer 0.6. So it only has a difference of 0.6 and not 0.7. So then I thought, well, I'm close. 0.6 is nearly at 0.7. So I thought, well, if I've looked at 0.8 and 0.2, what two numbers are similar to that, which also have a total of 1? So here I've chosen 0.9 and 0.1. And once you obviously add those two together, you still get the sum of 1. But again, my issue was when I did the subtraction, 0.9 take away 0.1, I got the answer 0.8. So I'm too high now. So as you can see, 0.8 and 0.9 are very, very close together. There isn't a digit in between that. So what I actually have to do is I have to go into the next place value. So I'm going to look at what is exactly between 0.8 and 0.9, which will be 0.85. So if I pop that up on the screen. Now I know when I'm adding the numbers together that it can't be 0.85 add 0.2 like it was in the original one, because that would give me a number that was too great. So actually it is 0.85 and 0.15 which add together to give me the answer of 1. And then when I do the subtraction, so I do 0.85 subtract 0.15, I find that I have actually got a difference of 0.7. So those are the two numbers there that are correct for this question. The next question, order the following from the smallest to the largest. So straight away I wouldn't even think about answering this question when I've got all those denominators that are different. Sometimes it's quite easy to spot, but for this one here, I would definitely recommend changing the numerators. The only thing that you can see straight away is that one of the fractions is 3 over 2. Now that is an improper fraction because you have got a numerator that's bigger than the denominator. Now because that's the only fraction where that is the case, I can already guess that that is going to be the largest fraction because it has got a numerator that is bigger than the denominator. But I would still probably go with changing all my denominators to the same thing. So what I did is I looked for a number that all of them have got in common, which is 20. So I turned all my fractions over 20 by multiplying my denominators to get to that number and then multiplying my numerators by the same one. And then what I can do is I can now start to see the answer here. So I have got I've got 35 over 20, 32 over 20 and 30 over 20. So what I would then do now I know all of these answers, is I would start to put them into the order that they would be in the boxes. However, I must remember that I have to put the original numbers back in that place, not the new numbers that we've multiplied by, okay? So I will put them into the correct place values for you, which you can now see on your screen. So actually 3 over 2 ended up being the smallest fraction, because obviously 8 over 5 and 7 over 4 are still both top heavy fractions themselves because the numerators are bigger than the denominators. So definitely using the method where you turn them all into the same denominator has worked better here.